Hey, I'm a weather nerd, and mostly because I'm an emergency manager. So my name's Eric Evans, and I work in the Office of Disaster Services. And I wanted to provide this to you so you can get a very simple approach to understanding weather across Missouri. Just the difference between yesterday and today should provide plenty of examples, but I'm going to also talk about maybe what's going to happen over the weekend. So these are the objectives. Really, it's just to give you the basic understanding of the weather patterns over the Midwest, specifically Missouri, and to empower you to prepare for that. I can't tell you how many people I ran into that don't have the right coat on, and I came from the MU campus where they would literally walk around in flip-flops in the snow because they didn't pay attention to the weather. Of course, they're always complaining about how cold they are. So if you can relate that to your work, as a matter of fact, weather is what brought me to you. The floods, the spring floods of last year brought me to DMH to run the crisis counseling program. So it's always something going on in Missouri, and it's always really interesting. So I'm going to oversimplify this. We don't have to get into scientific jargon, but there's 4 things you need to get a car going, just 4 things. And obviously you need to have the superstructure, but that's not one of them. So here's what you need. You need an engine, you need fuel, you need steering, and you need ignition. So engine, fuel, steering, and ignition. And all those I'm going to relate to different aspects of weather in Missouri. So let's talk about the engine first. The engine is weather fronts, and you see these on maps all the time. But fronts are nothing more than they're formed along lines of pressure. So you have 2 types. You have a high and a low. And when those things try to equal each other out, they can collide if you give enough fuel, and they cause different types of storms. So the collision is that engine. So here's the definition of a front, that is basically a boundary separating 2 masses of air of different densities. And when you start adding things into that air, that's when you have those big clashes that can create thunderstorms. So they differ by humidity, they differ by what direction they're moving, they differ by pressure. All those things go into fronts. So I'm going to show you a cold front, which is what we got last night. So we have a cold front, and with that cold front you see the advancing cold air, and you have the warm air going up over it, like we all know warm air does. And this is the sign for a cold front. It's the blue line with the triangles on it. Okay? So the blue line with the triangles moves along, and it clashes into warm, moist air. It climbs above that cold air, and guess what happens? You get a storm. Warm front, just a little different. This is the sign for warm front. It's got the red half balls there, and typically those signs are also showing you which way it's moving. So if it's facing to the east, which it almost always does in Missouri, that means that that front is going towards the east, the direction of the triangles or the half balls there. So warm front, typically warm air is also moist air. So again, it will climb above cold air, and when it starts congealing, we get rain. So the fuel for weather is moisture. And moisture is always in the air. Sometimes you hear it as relative humidity or dew point. Just ignore all that. If you ever hear a weatherman saying warm, moist air coming out of the Gulf and a cold front up north, guess what's going to happen? We're going to have rain or a storm or something like that. So our concern here is if a lot of moisture comes in the atmosphere and a low and a cold front come through, then we have a potential for really dangerous conditions, because that's what's going to cause the clouds, and that's what's going to cause the supercells, that's what's going to cause the lightning, all that other jazz that goes with it. Okay? So steering, you need steering. And steering is nothing more than the jet stream. You've heard of the jet stream before. It's really, really way high up there, but it starts about 30,000 feet, and it goes up 2 or 3 miles beyond that. And you'll see this example down here. The jets actually use the jet stream to move faster from west to east. But there's a northern jet stream and a southern jet stream. We're mostly affected by the southern one. And then, of course, Canada and along the border there is mostly the northern. So you can see 2 different storm systems cruising along, and you often do. So this is an example of jet stream. You see the northern one and the southern one. The southern one's coming down here, and it's all moving that way. And something's going on right here. This is going the opposite direction of that, so what do you think it is? It's a low, okay? So what's happening, and this is very similar to what's happening today, matter of fact, in Missouri and all across the southeast this afternoon. The jet stream has dipped down and is dragging all the weather with it right along the southern tier states today. So you need ignition as well. So ignition is when you combine the engine and you have the beginnings of a possible storm. So not all pressure systems cause storms. It all depends on all those other things mixing together to cause us to have storms. So, but when they are combined, that's when you get something exciting. So here's today's forecast. Haven't heard that before, have you? So what you have here is you have cold air that's come down because it's being pulled down by a high. That high is rotating clockwise. Lows are rotating counterclockwise. And it's pulling all this moisture up from the Gulf, and it's colliding right along this line. And today is going to be a wild day in Alabama and Mississippi and northern Florida and Georgia. Okay, so you may have heard that it's going to be a wild day. Matter of fact, it's a Category 4 system right now, and so if you have friends down there, I hope they're paying attention to the weather, because it could be a wild one today. And then I'll show you Sunday's forecast here in a minute. So high pressure. High pressure is when the air is actually pushing down on the earth because of high pressure. And typically high pressure comes with bright sunny skies, wind, often associated, could be associated with cold or warm air, doesn't really matter. But highs are frequently associated with very light winds. And the subsidence generally evaporate the clouds, so you almost never see a thunderstorm or rain when highs are dominating our area. Now, high pressure systems, remember that high pressure systems rotate clockwise. Knowing the way that the pressure systems rotate is extremely important in weather. Low pressure. Low, or short for short, is a region where the atmospheric pressure is lower in relation to everything else. So it's literally pulling things into it because it's rising up and it's sucking air into it, which is why you sometimes get very strong winds with storms, because it's literally lifting it up and throwing it back up into the atmosphere. So this will generally produce cloud cover and cooling. Typically brings cloudy or overcast skies. And in this time of the year, if all the things are correct and working together, you're going to get storms. So this is how I remember it. High clocks and low counters. So highs go clockwise, lows go counterclockwise. And when they start getting closer together, once they're literally pulling at the same thing, which really can cause some wild weather. Okay? This is called the Coriolis effect. And if you go beyond the equator and south of the equator, they spin exactly the opposite, which is I find very, very fascinating. So this is an example of a good-sized low. You'll see it's churning counterclockwise. So whatever it's pulling, it'll start pulling all this around it, and it'll pull anything down here into that low pressure system. So if there's a bunch of moisture in the air, it's going to pull it and lift it straight up into the air, and clouds are going to form, and depending on how deep or how strong that pressure system is, you're going to end up having rain with it. If not, you're going to have a very cloudy day. So this is an example. What's dominating here? Can anyone tell me what's dominating here? Well, just what I told you? I hear you. I see some people saying there's a low. In the center of that low's right there. Why? Because it's all wrapping counterclockwise. Counterclockwise. So thunderstorms. Now we're going to get into the wicked stuff. Thunderstorms form when that light, moist air typically is pulled out of the southwest or the south, out of the Caribbean, and collides with cool, heavier air. I'm going to catch up here. And if you combine that with a low, the lifting mechanism, and that warm air throws it up in the atmosphere, what's in the upper level of the atmosphere? Cold air. So you take warm, moist air and you throw it up in the atmosphere into the cold air, you end up getting clouds. And if you get a strong pressure system and it pulls enough moisture in it, you're going to get strong thunderstorms, perhaps supercells and tornadoes out of it. Hail, all that jazz. So these condense into the storm and they get dragged across Missouri by the jet stream. Pretty easy. Jet stream just grabs it and drags it along. You can see it every single day. So again, we have advancing cold air behind a cold front, which we did last night. Warm receding air, which is why all that's happening in the south. That warm air has been pulled out of the Gulf, and all those thunderstorms are firing off along that line of the front. So when you see these big clouds, and you see them every single spring and sometimes during the summer, but this is just a normal cloud. You may get rain with it, but it only goes up to about 20,000 feet. Okay? So you see these big clouds, and they're beautiful, and they look like elephants and all those other fun things that you can look at a cloud and see things in. But that's just a towering cumulus cloud. You're probably going to get a little rain, but more than likely you're not going to get a horrible storm out of that. But what happens when the pressure is really low and there's a big mass of those two systems running into each other with a lot of moisture, you're going to get big clouds and big storms, which is what's happening in the south. So this can be called what is a supercell. If you ever hear a weatherman talk about supercells, pay attention. Because whatever happens with that supercell is either going to be a wicked storm or it's going to be associated with perhaps tornadoes and hail and strong winds, all that other jazz that goes with that. So a supercell gets above 40,000 feet. And that's really, really, really cold air up at 40,000 feet. So if a low's pulling all that moisture up to 40,000 feet, you can imagine what's going to happen eventually. It's got to come down sometime. So the way we prepare for this is understand watches and warnings. You probably do. But a watch is the conditions are right for the development of this thing to happen. Typically you hear of a thunderstorm watch or severe weather watch or tornado watch. That just means the conditions in the atmosphere are right for it. And a warning means it's going to happen somewhere. It may not land on you, but it's going to happen somewhere in that watch area. So whenever you hear a warning, pay very close attention to that. But watches is what I like to watch too. So this is a supercell, and this is called an anvil cloud. You notice it looks sort of like an anvil. It's got a big wall right in front of it. And you can see these approaching, typically out of the west. And the rain and tornadoes will form down here because that's where the shear factor on the spinning is the greatest. Okay? So if you see something like this, you can do like they do in Kansas and Oklahoma, go get your camera and go outside. What I do is go to the basement and pray, because I've almost been taken out twice by tornadoes. Okay? Here's another one. Look at that anvil cloud. That's a beauty. Pretty fascinating. And you'll also notice, and you've probably seen this before, when you go out and you look at these things, they're actually moving. And if you see them kind of going counterclockwise, well, if you obviously see clouds, you know there's a low. But it'll be moving at the bottom, and that spinning is pulling all that air all the way up into the upper atmosphere, up to 40,000, maybe even taller feet. And that means there's going to be wicked, wicked weather. Here's another one. Look at that spin on that dude. You see that, Becky? Just beautiful. And terrifying. Look at that one. These are all from Kansas, Oklahoma, and Missouri. I see my buddy Joe back there. This is cool stuff. Really cool stuff. And it also means run. Run, hide.
Look at it for a minute, then run.
Yeah. Look at it and go, man, that's beautiful. We're dead. Are you from Oklahoma, Dave?
No.
Oh.
Indiana.
Okay. Well, you get these two from Indiana. So this is a beautiful, this is actually shot in Kansas, but I love this picture, so I just threw it in there. You got a tornado, you got a wall cloud, beautiful background, the sun's still shining on this side of the storm system, and you got a rainbow in it. It's just a gorgeous picture. I love that picture. So this is going to happen in 2 days. So does anyone want to try to describe what's going on based on what you've learned? It's a mess, yeah. Want to take a whack at it, Joe? Does anyone know what's supposed to happen Sunday?
No.
Please tell me you do. Yeah, snow. Possible snow. Luckily, they've reduced the forecast amounts. So what's happening here? There's a lot going on. And this is why I love looking at these forecast maps. There's so much going on. Obviously, someone up near Alaska is in deep trouble with that one. That's a very strong low. But here we got a string of low pressure systems with warm air, right? Because it's facing that way. And it starts getting stationary down here, which means they're just constantly banging into each other. Stationary fronts don't move a whole lot, okay? So you got this low, and again, counterclockwise, pulling air out of, and this is helping because there's a high going clockwise. So it's pulling warm, moist air out of Mexico, the Pacific, and the Caribbean. So they're literally sucking the air together at the same time, okay? Then you have this massive movement of the jet stream, woo, just like that. And you have all this high pressure, which is going counterclockwise, pulling that cold air down. So what you're going to end up having is you're going to, all along this line right here, you're going to start having cold, moist air colliding and causing snow. And in a couple of weeks, that's going to cause a heck of a rainstorm. So some indicators. You've seen some of the wall clouds, obviously. Hopefully you knew that they were coming. But if not, when the Weather Service starts issuing watches and warnings hours and hours in advance, that's not a good sign. I don't know if you all remember the storm of 2005, but 3 days ahead of the storms, the Weather Service was going, this is going to be bad. And that's highly unusual. I was in Nebraska teaching at that point, and they had hailstones the size of footballs. Killed cattle, killed people. But they were talking about 3 days before it even got there. So if they start saying severe storms, or they mention the word supercell, that means you all need to pay very, very close attention to it. Because you're going to get heavy rain, you're going to get strong winds, you're going to probably end up with wall clouds, and if there's a supercell, you're going to get hail. One of the indicators of tornadoes almost all the time is it hails right before the tornado strikes. It just does. Because guess what's up in the sky? It's up at 40,000 feet. That cold air is freezing that water and dumping it back on the ground. That's hail. So when you see hail, take a picture through the window, then go to the basement. So here's a couple of questions. Can storms occur without fronts or pressure systems, do you think?
Sure.
It's pretty rare, but they could. Like in the Caribbean, in Florida. Has anyone ever gone to the Gulf Coast of Florida? Okay, if you're on the Gulf Coast of Florida, it rains every afternoon at 2.
Yep.
Why is that? It's just because it evaporated all that moisture with the sun, and it has to come down. But there's no front associated with it. It's just what happens in Florida. Can it happen over Missouri? Probably not. Probably not. I wish it was like Florida and Missouri, but it's not. Can tornadoes occur without a supercell? No. It has to go way up in the atmosphere to get all that energy built up, and then once that shear starts, it'll drop a tornado. Now, you can have funnel clouds all the time. What is the definition of a tornado? It's when that cloud becomes a spiraling mass of air and actually touches the ground. So it's not a tornado until it actually touches the ground. Okay? Can radar see all storms and tornadoes?
No.
Remember what tornadoes are. They're air. Radar can't see air. What they can see, though, is the mass of moisture in the air with the clouds and see the spinning of that and then make an educated guess that there may be a tornado involved in it. And then someone calls the Weather Service and says, there's a big tornado. And they go, yeah, we thought there might be. Okay? So I lived in Columbia, Missouri in 1998 on the south side of town, and we had a very small EF0 or EF1 tornado hit my neighborhood. No warning whatsoever. The reason why is curvature of the earth. The St. Louis radar is looking west, the Kansas City radar is looking east, and they top out at about 40,000 feet above Columbia, and right there is where the tornado fell. And no one knew it. And it looked like a war zone. And it was a very small tornado. Do tornadoes bounce?
Yes.
No. You think they do, but they just go up into the cloud and come back down, but they don't actually bounce along the ground because it's just air. Oh, that's your bounce. Okay.
That's the quotes.
Okay. Does a tornado bounce over cities because of heat domes? They don't bounce. You're right. You know, there's several examples. Do you all remember when Nashville got hit with a tornado? Wasn't that long ago, it was a few years ago, maybe 5. Downtown Nashville. The tri-state tornado of 1925, 3 states long. 295 people died in that. The Great Tornado of St. Louis in 1908, 600 some odd people died in St. Louis. So they don't bounce, and they can happen anywhere. There does seem to be a correlation between cities, but if it's a big, strong enough low, nothing's going to stand in the way of it dropping a tornado on you. So why do tornadoes occur mostly between March and June in Missouri? What? You're making great signs there, so you're getting ready to be a weathercaster, I can tell.
Having glasses.
Yeah, yeah. If you look at what happened between yesterday and today, yesterday 67 degrees. This weekend, record temperature lows for April. And if you combine that, like it's happening down south today, with that strong low, boom, boom. So I encourage all of you to download weather apps. They're free. I think KMU is a good one, but when you can only have your phone a certain way with KMU, which kind of drives me crazy. But the one, I think the best one is Storm. It's by the Weather Underground, which is an offshoot of the Weather Channel. If you just type in Storm into one of the stores, you'll get it for free. There's a non-free version which costs almost nothing. And then they also just added a new high-definition radar to Storm that you can download as well. So if you want to look at radar really closely in high def on your phone, so there's Storm and there's Storm high-def radar. I have like 4 or 5 weather apps on my phone just because I like watching that stuff. But so what? Excuse me. What weather phenomenon is responsible for the most deaths in the United States? Yeah, what I hear?
Flood.
Yeah, what kind? Flash.
Flash.
Flash flood. You know those barricades that everyone drives around?
Yeah.
They're there for a reason. Well, thank you all for coming. I hope you learned something, and pay attention to the weather, especially in the spring. They're already talking about it being pretty wicked. Thanks.